Good evening, children. In this class, I am discussing exercise questions 2.2 in page number 36 onwards. This is the fifth day in discussion with similar triangles. So let us have a look on the exercise questions. Exercise 2.2. Already I have told you to go through questions of first main. Even you might have solved it. I am trying to explain those questions. Already the figure is with you in the textbook, page number 36. So the first question is, there is a triangle where length of AD is given, length of BD is given, and AE is also given. You are supposed to find CE. So use Thales theorem and write the ratios. AD by BD equal to AE by CE. You write as a ratio. Why you are supposed to use Thales theorem? The reason is simple. They have given that DE is parallel to BC. When DE is parallel to BC, easily you can use Thales theorem. Put the values. Value of AD is 1.5 and that of BD is 3 and AE 1 centimeter. CE is not known, take it as X. Then further cross multiply, you get 1.5 into X equal to 3 into 1, that is 3. Once you know 1.5x equal to 3, X equal to 3 divided by 1.5. 1.5 means 1.5. This is 3. 1.5, 2 times the 3. So value of X become 2 centimeter. That means length of A is 2 centimeter. This is the first question. Hope many of you have done already. Similarly, first main second question can be solved in the same way. Figure is there in the textbook. Ratios I have given by using Thales theorem. I have substituted the values. Simplification only I am explaining here. I have X by 7.2 equal to 1.8 by 5.4 where AD is not known. So I have taken it as X. Next, X by 7.2 equal to 1.8 by 5.4 is simplified as 1 by 3. How to simplify? Decimal points you can neglect because there is one digit after the decimal point both in numerator and denominator. When the number of digits after the decimal point are equal in both numerator and denominator, you can neglect. Or in the same case, you can multiply by 10 in both cases, then also decimal point will go. So 18 on the 18, 18 is the 54, so it is 1 by 3. Further cross multiply, 3x equal to 7.2 you will get, or x equal to 7.2 divided by 3. I have not written there. So that is 7.2 divided by 3 became 2.6, I hope so. It is 2.4, not 2.6, it is 2.4 centimeter. I have not done the simplification process. 7.2 by 3, 3 to the 6, 1 remaining, 3 for the 12, so I have got 2.4 centimeter. So these two are the first main questions. Then coming to second question. Second question, there are 3 sub questions. Same figure you are supposed to apply for all. E and F are the points on PQ and PR of a given triangle PQR. Now what they are giving? They are giving certain values. Values for PE, QE, PF and FR. You should try to find out by using those values whether EF become parallel to QR. So our question is to verify whether EF is parallel to QR. How can we verify? If the side ratios are equal, that is P by QE equal to PF by FR, then EF is parallel to QR. So second main, first question. Values are given. P as 3.9, EQ is 3 is CQ. And let me write here only. P as 3.9, EQ is 3, then PF is 3.6 and FR is 2.4. By with these values, whether EF become parallel to QR. So, if EF is parallel to QR, then P by EQ will be equal to PF by FR. After putting the values, 3.9 by 3 should be equal to 3.6 by 2.4. Now, 3.9 by 3, 3.6 by 2.4, similarly I am simplifying. Points are neglecting. 36 by 24. 36 by 24 is 12 to the 24. 12 3 the 36. Now we can check whether they are equal or not. It's easy. Just cross multiply and see. 3.9 into 2 become 7.8. 3 3 the 9. They are not getting equal. That means these ratios are not equal. Once you can understand the ratios are not equal, we can easily say EF is not parallel to QR. Condition I have taken is, if EF is parallel to QR, then P by EQ will be equal to PF by FR. So in the first case, it is not possible. Similarly, second question you can do only by changing the values. Values are given there, substitute the values and try to find out if they are equal, then EF will be parallel to QR. I have done the third question for you. Second main, third one. Similar way, same figure, but here PQ is given 1.8. This is PQ, 1.8. And P is 0.18. PR is 2.56. And PF is 0.36. This one. See now, they have not given P they have given, EQ they have not given. It is your choice now. You can find EQ. How to find EQ? In PQ, subtract PE, you get EQ. In PR, subtract PF, you can get FR. Then you can try to find whether they are EF is parallel to QR or not. You have an underwriting. You know, in the I think third class I have discussed. Now when you have drawn a line, if it is parallel, then you will have two similar triangles. One smaller one PEF, another is PQR. So directly I am taking, what I am taking? If EF is parallel to QR, then you can have two similar triangles. What are they? Triangle PEF and triangle PQR. You can also write PQ by PE equal to PR by PF. Directly you can write without getting the values. You can do alternatively like that also. So PQ is the side of a bigger triangle. P is the side of a smaller triangle. PR is the side of a bigger triangle and PF is the side of smaller triangle. So I have written PQ by PE equal to PR by PF. Put the values, all the values are given. 1.28 by 0.18 equal to 2.56 by 0.36. Are they equal? If they are equal, then EF is parallel to QR. Simplify. 2 digits are there after decimal point in either case. Here also, everywhere you can neglect the decimal points. You can write 128 by 18 equal to 56 by 36. Are they equal? How to find? Just cross multiply and see. Or you can observe 128 to the 256, 18 to the 36. So they are same fractions. So that means they are equal. Once left hand side and right hand side are equal, you can write EF is parallel to QR. So in the second main I have done two questions, and second question I have left it for you. Second question is very similar to the first one. So now coming to third main. In third main there is a figure. Again figure I have drawn here in order to avoid confusion. If LM is parallel to CB, what they have given here is LM is parallel to CB, LM is parallel to BC. You are supposed to prove AM by AB, AM small one, AB for bigger triangle, equal to AM by AB. So what you are supposed to do is, you are supposed to take similar triangles. Similar triangles you can observe now. Forget about the bottom portion here. You can close this. You can observe triangle ABC and L. LM is parallel to BC in triangle ABC. So AML is smaller triangle, ABC is bigger. So I have written in triangle AML and ABC. In triangle AML and ABC, you can write AM by AB equal to AL by AC, because they are similar triangles. You can use Thales theorem, you can write as Thales theorem. Actually, it is a corollary of Thales theorem or the result obtained from Thales theorem. That means whenever you draw a parallel to one side of a triangle, you have got two similar triangles. So now I have got AM by AB equal to AL by AC. Now observe the bottom portions, these two, what I am shading now. Here also you can see two triangles, triangle ALN and triangle ACD. LN is parallel to CD. You can write AN by AN is the side of a smaller triangle, AD is the side of a bigger triangle, equal to AL for smaller triangle, AC for bigger. I have written here. So what can you observe? From these two equations, right hand side is equal for both. So you can combine them and you can write their left hand sides are equal. That is AM by AB equal to AM by AB. That's what you are supposed to have to prove. So thus we have completed exercise questions 1, 2, 3. And exercise question 4 is also similar to that. So you may try exercise question 4 for today's class. Even this question also I will be explaining. And many of the cases where the questions are more trivial or simple, I will try to explain half only, but it becomes difficult for you to understand. So I have explained once, so go through.